Hey everybody, welcome to Pre-Calculus. This is your first unit. It is on polar coordinates and equations. And we're going to introduce a whole new coordinate system. And let's go ahead and get started. Okay, so we're going to first begin and talk about the difference between the Cartesian coordinate system and the polar coordinate system. Your Cartesian coordinate system is basically what you've been working with for since you began algebra and you were working in graphing points. So this is your XY system on your XY coordinate plane, and where you would graph X as in the horizontal direction from the origin and Y as in the vertical direction from the origin. So you'd go ahead and plot any point knowing where to move based on the values of X and Y. If X and Y are positive, then you would move to the right and up, and if X and Y were negative, you'd move left and down. So that's just the system that we've always been working under. So to introduce the new polar coordinate system to you, it's going to be based on a few things, and the system begins with something called the pole, P-O-L-E, okay? And the pole has a ray called the polar axis, and the polar axis is more of a directional, and we're going to begin with our polar axis with the pole at the origin and then the polar axis lining along the positive x-axis. So this is where we're going to place it, so that if you were to take a point that you plotted in the the Cartesian coordinate system, xy, you could actually relate it very similarly to a point that is in the polar coordinate system. Now in the next video, that's what we're going to do, is we're actually going to be converting between these to see the relationship that they have. So you're going to get a little bit of that here, but we're not actually going to be converting. We're going to merely just be plotting. So if all you walk away with from this video is how to plot these points, you've taken everything you needed. All right, so let's suppose we do have a point xy out here in our first quadrant. So to graph this, we knew we had to move to the right and then up, and that's how we got to where, oops, I didn't want the eraser. That's how we got to where we were going. We went a certain direction or certain distance to the right, and then we went a certain distance in the positive y direction, so that gave us our two directions. Now, if I were to use our polar coordinate system to work with that same point and identify it, we're going to be talking about another ordered pair, but this one has r, which is the radial measure, and our radial measure is actually defined as the distance from the pole. Oops. Now, if the pole is centered at the origin, then we're really talking about the distance from the origin. Okay? And then your theta value is going to be the angle measure, or a measure of rotation, in a counterclockwise direction, starting on the positive x-axis. Now this is exactly the same way that we've always measured our angles. We started with a positive x-axis and we moved in a counterclockwise direction as we rotated around the circle. So I'm going to go ahead and draw an angle. So this would be our theta value. And then if I connected the pole to the xy coordinate that we were using, I would be able to call that r. So the two things that are important here for your polar coordinate system is the angle that we moved and that distance from the pole, or the radial measure. Let's go ahead and plot some points. So here are three examples of some points using the polar coordinates. So point P is 2, 30 degrees, and we're going to go ahead and plot that. And we actually will begin with the angle measure. It's always easier to begin with the angle measure. So I'm going to draw 30 degrees here. So r equals 30 degrees, or excuse me, theta equals 30 degrees. And now when we talk about the radial measure comes from the word radius. So if I were to have these small circles that were centered around the origin and they were to gradually increase in radius or in size, if I wanted 2 to be my radial measure, then I would be on the second unit circle from the origin. So this has a radius of 1. This second one has a radius of 2. So the point that I'm going to plot is 30 degrees from the positive x-axis and is on the second radius, a radial circle from the origin. So this would be point P, the second radius. Okay, so let's go over here to point R. I'm going to go to 120 degrees, which is in the second quadrant. So there's my theta equals 120. And if I wanted to, again, look for the second radial circle, I'm going to use these little arcs to represent this. So this would be my first radius and my second. So as I plot this point, then this would be point R. So rather than drawing all these circles around there, I have some special graph paper that actually has those circles drawn for us on there. So it looks like a big bullseye, and we would be on the second ring to get this R value of 2. Let's try the next example. 350 degrees is almost all the way around the circle. So I'm going to draw that long radius there, and then we're going to measure 3.5. So 1, 2, 3, 4, and then I can go ahead and place the point that I'm looking for, point Q, at 3.5. Let's give a couple more of these a try. All right, so example 4 is point S. And if you notice something different about these is that the radius is measured in a negative. So we're going to have to take a look at that. And I want us to not think of it as negative, but I want us to think of it more like a reflection or an opposite value. So we're going to start by looking at 45 degrees, just as we had done before. So there's our 45 degrees. And then instead of going in the positive 2 direction, we actually have to imagine this being a reflection through the pole, because our pole is here at the center. We want to go through the pole, and this represents -2. So anytime you see the negative, you're actually going to head in the opposite direction along that pole, or along that polar axis, and you end up right here, and that is point S. Let's try that again with example number 5. So 150 degrees, so we're going to draw that. 150 is over here. And then if we were to trace that all the way through, if we were to trace that all the way through, and then I wanted to use 5 units from the pole, then this would be my point here, T. All right, let's mix it up even more. What if it's a negative angle? Well, for a negative angle, we're going to do what we did in the beginning of the year, where we just went clockwise. So let's try point U. So we're going to start by heading -60 degrees. So instead of going up, we're actually going to go down 60 degrees, so in the clockwise direction. We'll draw that radius out there, and then we'll go ahead and put 2 marks, and we'll call that point U. So here we had theta equals -60, if you want to mark that. All right, example number 7. So for this one, not only do I have a negative angle, but I also have a negative radius. So this is going to be taking into account a couple different ideas, starting with -95 degrees. Well, if this is 90 degrees as I'm heading in the negative direction, then -95 degrees is over here. So this is the radius I'm on. Now, because I have a negative radius value, I'm going to actually go this way, And then I want to go out 5. 1, 2, 3, 4, 5, and there is point V. Once again, we went negative, so we went clockwise for our angle, and then we had to go through the pole because of our negative radial measure. All right, an important difference between the Cartesian coordinate system and the polar coordinates is that there is a given a point in the plane where only one Cartesian pair of coordinates can exist. Let me say that again. So basically, if we're working with a Cartesian coordinate system, the one you grew up with and that you're very familiar with, there's only one place where x, y can be located. For example, if I give you 2, 5, there's only one place that can be described as 2, 5. If I start changing 2, 5, it's no longer the same location. This is not true with the polar coordinates because they can have an infinite number of pairs of polar coordinates. So we're going to look here at example number 8. So for example, 3, 140. I'm going to start by graphing 140 degrees over here. And let's go ahead and 1, 2, 3. So here is the point that we're talking about, 3, 140 degrees. Well, this isn't necessarily the only way that I had to get to 3, 140 degrees. For example, what if we decided to use a negative angle measure and we went this way to get there? What angle measure would we use to get that? Well, we subtracted 360 degrees. So it has the same radial measure, still needs to be out 3 units from the pole. However, we would use 360 minus 140, or vice versa, and we would say that this was negative 220 degrees to get there. So this theta is negative 220, but we know that they terminate at the same place. So we're using our terminal measures again. So there's one way. Another way is, what if we actually over-rotated and we went around? So I'm going to grab a different color. We're going to do each of these differently. So now I'm going to say, well, we're going to pass that point and we're going to come back around and we're going to end up there. So what does that theta value equal? Well, it still has a radial measure of 3. But this time I'm going to take 360 and I'm going to add the 140 because that includes the single rotation all the way around plus the 140 we needed. So we can actually say that that's 500 degrees. So we could, of course, keep adding positive and negative 360 until we come up with all of these different values. Again, we could do another negative 360 on this green one and we could just under-rotate so many times. And then there's this other possibility that exists where we not only have, or where we have a negative radius. Well, how do we come up with that one? So grabbing another color yet here, let's try purple. That if this is 140, and I wanted to look over here at this measure, how can I get it to go from the positive x-axis to here and then through so that we land in the second quadrant? Well, if this measure to get back to this is 40 degrees, so in other words, from my 140 down to the 180 is 40 degrees, then using vertical angle idea, then this purple angle over here is also 40 degrees, negative 40 degrees. Oh, interesting. So if that is a negative 3, because we're going to go through the pole, and a negative 40 degrees. Finally, I'm going to come up with one more, and that is to rotate. Let's grab a whole nother color here. How about orange? If I rotate from the positive x-axis all the way around here to this negative pole and then go through. Well, if this was 40, 360 minus 40 means that in the positive direction here, I'd actually be going 320 degrees. So this gives us one last one. Oops, positive 320. Make sure that says positive. So these would be just a variety of ways to get to exactly the same pair. Back in the Cartesian coordinate system, we had one way to do this. In the polar system, look at all of the things that mean exactly the same place. Okay, I'd like you to try examples 9 and 10 on your own, and then we're going to discuss those first thing tomorrow. Identify two other pairs of polar coordinates for each point, just like we did in example 8. Now, I want you to know that you must come up with one that has a positive r value. So you have one with a positive r value. I don't know what that says. And then one that has a negative r value. And that's really important because you're showing me quite a bit of difference. To get another positive r value means that you're just going to go ahead and add 360 or subtract 360. But if you can come up with another one that has a negative r value, then you're really considering the idea of traveling through the pole and on that reflection line. So make sure that you're able to do both of those things. All right, so just a quick summary of what we covered here. We actually introduced you to a new polar coordinate system, and we talked a little bit about the relationship between the polar coordinate system and the Cartesian coordinate system. If you can walk away from this video being able to graph polar coordinates, and if you're able to write other representations of the same point, then you've gotten everything you needed from this video. So please take plenty of notes. Make sure you go back and watch anything, especially the part where we were talking about writing different representations of the same coordinate, and that was example number 8. And then we'll take off from this in class.